So again, a trinomial is going to be of the form ax squared plus bx plus c, usually. And when you look at this form, there's two ways to approach factoring here. If a is equal to 1, so if the leading coefficient is 1, okay, the steps that you would use to factor this are the reverse FOIL process. So if I gave you something like this, okay, what you do to reverse FOIL is you look to see, you know that your first terms of your binomial factors have to multiply to equal x squared. So the only combinations you have when the leading coefficient is 1 is x and x. Your last terms need to have a product of negative 12, and then the outer plus inner products has to equal positive 4. Okay, so when you look at this, the way to approach this is what you guys have probably already learned, which is, are there factors of negative 12 whose sum is positive 4? Positive 6 and negative 2. And so those would be your factors. You can test it by foiling and confirm that this, in fact, will expand to the trinomial that you were factoring in the first place. Okay. My thoughts are you guys should be very comfortable working with any factoring where the leading coefficient is a 1. Okay. The question comes, what happens when the leading coefficient is not 1? Okay. You have two choices when this is the case. So let's take the example of 4x squared minus 11x plus 6. Okay. One possibility, and the one that you guys have probably been taught, is trial and error, which is just reverse foiling. Okay. And so again, if you're thinking, here's your f and L, your outer plus inner has to equal negative 11. So if that's the case, if you're going to use trial and error on this, you need to test all possible combinations. So we have 4x and x, or 2x and 2x. Those are the only two combinations of our first terms that are going to give us 4x squared. The combinations of our last terms to give us 6 are 6 and 1, 1 and 6, 2 and 3. Oops. Let me go back there real quick. As far as looking at the signs of these terms, since your product is positive and the sum is negative, you know that the sign has to be negative as well. So we're looking at negative 6 and negative 1, negative 1 and negative 6, negative 2, negative 3, or negative 3, negative 2. So here's all the possible combinations that you can test. So it winds up being 8 different combinations, if you're using trial and error, that you'd need to test in order to come up with a right solution. Okay? And that's fine. If you're comfortable doing this, you can go through and test these and come up with the right solution. I'm going to show you a different method for solving this. And the reason I prefer this method is it's more efficient. It'll always get you the right answer the first time you solve it, so that you don't have to waste time testing anything. Okay? So here's the process that you would use. Okay? The first thing that you're going to do, and this is if your leading coefficient is something other than 1, is you take the product of A times C. Okay, so you're going to take the leading coefficient times the constant. So what is 4 times a positive 6? 24. Okay, notice I write it right beneath the middle term. Okay, once you take that product, you're going to find factors of this product AC, whose sum is the B value, the middle term's coefficient. So what factors of 24 have a sum of negative 11? What two numbers multiply to give you 24 but add to give you negative 11? Negative 8 and negative 3, right? So once you find those factors, what you're going to do is you're going to rewrite the middle term as the sum of the factors from this step number 2. So if I rewrite negative 11x as minus 8x minus 3x, did I change its value at all? I didn't change the value. It's still equal to a negative 11x. But all I'm going to do is I'm going to drop down my first term and my last term. And then my final step is just to factor this resulting expression by grouping. So using the methods that I talked about on that first slide today, we can now factor by grouping. So if we pair the first two terms, what common factor can I remove? A 4x, right? And that's going to leave x minus 2. And what common factor can I remove from the second pair? Minus 3, and that leaves an x minus 2. If I've done this right, I'm going to have a common binomial factor. So x minus 2 can come out. And then what's left for my remaining factor? 4x minus 3. Okay, so here is my final solution. Now, if we had done this by hand, it would have taken us 4 attempts before we found the right one. Okay, so it's a little more efficient to do it this way. And now the question always comes up, well, how do you know to put the negative 8 in front of the negative 3? And the answer is it doesn't matter. Okay, let's say we test this if we had written it the other way. 4x squared minus 3x minus 8x plus 6. So when you rewrote the middle term, if you just split it into negative 3 first, then the negative 8, would it make any difference? This first pair of terms, we can remove an x, leaving a 4x minus 3. In the second pair of terms, we can remove a negative 2, leaving 4x minus 3. Our common factor is 4x minus 3. The remaining terms, x minus 2. So it does not matter.